Alright, final video, and it is factoring perfect square trinomials. We multiplied them earlier, and now we're going to factor them. This is just a real review. Remember what the square of a sum looked like? So this is the square of a sum, and this is what we did. This is the square of a difference, and this was our shortcut and what we did. And now we're going to start here and work our way backwards. Alright, here are two examples if you want to go back and review it. The quantity x plus 7 squared. Here's what we did to factor it out. Remember, if you can't remember the shortcut, you can always write that quantity x plus 7 twice and FOIL it out, and you're going to get the same answer. And here's a review of a problem with the subtraction. So if you need to, pause the video, take a little bit of time and look at it to remember what we did. Alright, so a perfect square trinomial. Perfect square trinomial are trinomials that are the square of a binomial. Alright, and here's our key concept. Actually, if a trinomial can be written in this form or this form, then it can be factored. So the a squared plus 2ab plus 2b, it will factor as a plus b quantity squared. If it is a squared minus 2ab plus b squared, it's going to factor as a minus b quantity squared. Alright, so when you're looking to see if something is a perfect square trinomial, really you're just basically asking yourself three questions. First question is the first term a perfect squared? And 16 is a perfect squared, and x squared is a perfect squared. So your answer to this is yes. The first term, 16x squared, is a perfect squared. Now, is the last term a perfect squared? Well, the square root of 64 is equal to 8. So yes, it's a perfect square. Then you're looking to see if the middle term is equal to the square root of the first, and the square root of the first is 4x, times the square root of the last, which is 8, times 2. So 2 times 4 times 8. What is 2 times 4 times 8? Well, 2 times 4 times 8 is 64. So guess what? This one is not a perfect square trinomial. Alright, next example. Same three questions. Is the first term 9y squared a perfect square? Yes, it is. Is the last term 4 a perfect square? Yes, it is. So now, is the middle term equal to, this is square root of the 2 times square root of the first times square root of the second. 2 times 3 is 6. 2 times 2 is 12. So that's 12y. So yes. So now, if it is, all you have to do is to factor it is. It is the binomial squared. It is, middle term is negative, so there's a minus sign between it. And now all I have to do is take the square root of the first term, which is 3y, and square root of the second term, which is 2. And we're factored. Alright, now let's look at this example. It's very similar to the other one, just a minor difference. There's a plus in the middle. So, but the same three questions. Is the first term a perfect square? So 9y squared. It's a perfect squared because its square root is 3y. So it's a perfect square. It is the last time a perfect square. Last term is 4. Square root of 4 is 2. So yes, it's a perfect square. And does that middle term equal to 2 times the square root of the first times the square root of the last? 2 times 3 is 6 times 2, so that is 12y. So the answer is yes. So we're going to factor it. And to factor a perfect square trinomial, you have a quantity squared. And you take the square root of the first, square root of the last, and because this middle sign is plus, you put a plus between them. So now it's factored. Alright, even if it has a fraction, it can still be a perfect square trinomial. Same three questions. Is the first term a perfect squared? Y squared, square root of y squared is y, so it's a perfect square. Is the last term a perfect square? 1/4. Square root of 1/4 is just equal to 1/2, so it's a perfect square. And is the middle term equal to 2 times the square root of the first times the square root of the last? And 2 times 1/2 is 1. So the answer is just y. So the answer is yes. So it factors into the quantity squared minus, so there's a minus sign between them, square root of the first term, which is y, square root of the last term, which is 1/2. So it is just the quantity y minus 1/2 squared. Alright, now here's a table for you. Since we have covered all the methods of factoring, here is just the little table for reference. So first of all, if you have 2 terms, the only thing what you're going to look for, 2 terms or more, GCF. Always look for this first. Alright, then next, if you have 2 terms, look and see after the GCF if they're difference of squares, and then you're just going to factor them like our difference of squares. Now, if you have 3 terms, first you're going to look for the GCF, and if not, you're going to check to see if they're perfect square trinomial, and you have your shortcuts to factor them that way. And then you're going to look for our first factorization of trinomials, where the term in front of the coefficient in front of the x squared is 1. Or, if it's not 1, you're going to use our slide and divide method. So you want to use the slide and divide method. And then, if there's 4 or more terms, the only way to factor is by grouping. Alright, so here's some for you to practice and try with. So why don't you pause the video, give them a shot, and then start it back up to check your answers. So let's try working these problems now. Alright, so here's the answers I got. Check your work with mine, and if you have any questions, just ask. One last thing I want to cover with you, and it's called the square root property. Okay, so basically what the square root property says is whenever you take the square root of a number, you're going to have 2 values, possible values, just like with the absolute value. You're going to have a positive answer and a negative answer. And here's an example. If I take the square root, x squared equals 9. So to get rid of the square, I have to undo the square with its opposite, which is the square root. And when I take the both square root and square cancel each other out, and I'm left with x. And because I'm taking the square root of the number, I have to have a plus and minus answer, and I take the square root of 9, and it's 3. So my answer is plus or minus 3. Because if I have 3 times 3, it'll give me a 9. But if I do a negative 3 times a negative 3, it'll also give me a positive 9. It's sort of a similar concept to the absolute value when we did it. Alright, so here's 3 problems that use the square root property, and I'm going to go through and do those with you and show you how to do them. First of all, when we do square root, we got to get rid of the square, so we have to do square root of both sides. Square and square root cancel out, and I'm left with a plus 4. Square root of 49 is 7, but remember I had to do a plus 7 and a minus 7. So basically I have 2 problems here. I have an a plus 4 equals a positive 7, and an a plus 4 equals a negative 7. So when I solve both of these, I'm going to get a equals 3 when I subtract my 4, and I'm going to get a equals negative 11. So I have 2 solutions to this one. Alright, second one, it's the same thing with the square root property. You just don't know it yet. This is a perfect square trinomial. This one is squared, this one is squared, and if I take the square root of the first, multiply it by the square root of the last, and then I multiply it by 2, I get 4y. So that means I can factor it by square root of the first, square root of the last to the quantity squared, and minus sign in the middle equals 25. Now to solve this equation for y, I've got to use the square root property. So I have to take the square root of this side to get rid of the square. So it gives me y minus 2, and I got to take the square root of this side, which gives me plus or minus square root of 25 is 5. So now I have y minus 2 equals a positive 5. Y minus 2 equals a negative 5. So if I solve both of these equations, I'm going to get both my solutions. So y equals 7 is 1, And the other one is y equals -3. Alright, so hey, last example. So I know that I'm going to solve with the square root property, so I'm going to undo my square with my square root. Undo this. If I had to do on one side, I'll do on the other. Square and square root cancel out, and I have x minus 3. Alright, now what happens? This 5 is not a perfect square. So all you can do when it's not a perfect square is you just put the plus or minus, and then you put the square root of 5 there. And now I have two problems to solve just like before. It's equal to a positive square root of 5, and it's equal to a negative square root of 5. Alright, so I have got to add 3. Okay, here's the tricky thing about this. 3 is not underneath a square root, 5 is. They're not like terms because the 3 doesn't have the square root. So all I can do with my answer is put 3 plus the square root of 5. And when I do the plus 3 over here, it's the same thing. It's going to be x equals 3 minus the square root of the 5. And you actually might see that problem written, and the answer written is just x equals 3 plus or minus the square root of 5. That means I have two answers. One is 3 plus the square root of 5, and the other one is 3 minus the square root of 5. And guess what? We are at the end. Yay! That's it for the polynomial review.